Hello guys, welcome to Ramta Solutions. Welcome to your lesson on differential calculus. Today we are looking at equation of a tangent to a curve. Okay, so we will begin by giving you an introduction of what do we mean by tangent to a curve, and then proceed to doing maybe two examples to help you understand this concept. Okay, all right. Now let's begin. So we're talking tangent to a curve. All right, we're talking tangent to a curve. So I want you to imagine a curve. Let's call it f of x. Okay, let's call it f of x. And let's imagine a tangent passing f of x. So this one here will be a tangent. It touches f of x at a point. So this is a tangent. It touches f of x at a point here. So remember, a tangent touches a curve only once. Okay, it touches a point only once. So at this point, let's call it point x, and its corresponding y value, let's call it y. Okay, so in the previous, especially the opening video, the first video of differential calculus, I told you that first derivative is what we call a gradient, right? And we said that is gradient to a curve. So when we want to find a gradient at a point, we can basically find the first derivative of that curve and then substitute whichever x value into that gradient formula. Okay, remember, gradient is first derivative, meaning f prime x. Okay, now we have our tangent. In addition to the tangent, we can also find what is called a normal. Okay, we can also calculate what is called a normal. So a normal is perpendicular to your tangent. Okay, your normal, just like the tangent, okay, I think I should just say your normal is simply perpendicular to your tangent. Okay, your normal is simply perpendicular to your tangent. Okay, so if you were to be asked to calculate gradient of a normal given gradient of a tangent, you will use this formula here. You will say gradient of a tangent multiplied by gradient of a normal. So the product of these two is equal to -1. Okay, the product of these two is equal to -1. Okay, now without wasting any time, let's show you the steps that you need to take in order for you to calculate the equation of a tangent to a curve. Okay, so in determining the equation of tangent to the curve, the first step you do is to find the first derivative of that curve that's given. Secondly, you will be given a point. Calculate or substitute that point that you're given into the first derivative formula to find the value of the gradient. Okay, to find the value of the gradient. Lastly, you can now determine the equation of a tangent using either, let me change the color, using either y equals mx plus c, or you can use y minus y sub 1 equals m into x minus x sub 1. Right? You can do that. And this is how you can calculate the equation of your line. Okay, this is how you calculate the equation of your line. Right. So this is what you need to do. So now, before I proceed, I must tell you, remember, on these two formulas, you need corresponding y value. If you are only given a point x equals whatever, substitute that x value into the original equation of the curve. You will find the corresponding y value. You will see this shortly. Okay, so let's start with our examples. let's start with our examples now. So example 1 will say, find equation of a tangent to a curve f of x equals x cubed plus 2x squared minus 7x plus 1 at x equals 2. Okay, so this is the curve. You don't have to draw these curves because some are really complex, like this one. So far, you don't know how to draw this curve. Okay, so far you don't know how to draw this curve. It's a cubic function. You will only learn about it in the next few videos. So remember, to answer this question, let me change the color. We say f of x equals x cubed plus 2x squared minus 7x plus 1. We need to find the first derivative. What is the first derivative? The first derivative is f prime x. This is 3 into, remember, 3 not into 3, you drop the power, you left with 3 minus 1, plus 2, drop the power, and then 2 minus 1, plus 7, the power is 1, drop it, and then it's 1 minus 1, and this is a constant, so it's 0. What's your answer? It is 3x squared plus 4x plus 7, because this is x to the power 0. Or maybe let me just write this. Okay, so this is x squared plus 4x plus, is it plus or minus? It's minus, yeah, it's minus, not plus. It's minus. Yeah, it's minus. So it's minus 7, right? It's minus 7. So this is the equation of your first derivative, right? So in order for you to find the gradient, remember, this is the equation of the gradient. Now to find the value or the gradient at a point, what point x equals 2? We'll say f prime of 2. So f prime of 2 means where this x we put 2, right? Where? On f prime of x. So it's 3 into 2 square plus 4 into 2 minus 7. Let me confirm. Yes, with this x I put 2. So let's get this. This is 3 times 4 is 12 plus 8 is 20 minus 7 is 13. So f prime of 2 is 13. This is your gradient, right? This is the gradient at a point. Alright, this is the gradient at x equals 2, meaning gradient at a point. Be careful, we do not have corresponding y value to this. So what do we need to do? We need to find f of 2. F of 2. What are we saying? On f of x, where there's x, we put 2. So this is 2 to the 3 plus 2 into 2 to the 2 minus 7 into 2 plus 1. What is this? This is 8 plus 1, so it's 17 minus 13. So 17 minus 14. The answer is 3. The answer is 3. Therefore, our point is 2 and 3. Okay? The point here has x value 2 and then y value 3. Alright? X value 2 and y value 3. Alright? X value 2 and y value 3. So let's find the equation of our tangent. So our tangent is, I will use y minus y sub 1 equals m into x minus x sub 1. You can also use y equals mx plus c. It's still okay. The point given is 2 and 3. Where there's x I put 2, where there's y, to be precise, where there's x1 I put 3, where there's y1 I put 3. So this is y minus 3 is equal to, what is our gradient? It was 13. 13 equals x minus 2. This is y minus 3 equals 13x minus 26. Therefore, y equals 13x minus 23. If you are using this formula here, you will be saying the point is 2 and 3. Where there's x, you put 2. Where there's y, you put 3. So what do we have? 3 equals, the gradient was 13. We said x is 2 plus c. So 3 equals 26 plus c. Therefore, minus 23 equals c. Therefore, y equals 13x minus 23. Okay, this is the equation of your tangent. So what if we're looking for the normal? I just want to add this one once and for all. Let me just looking at a normal. Let's find a normal. Okay, let's find a normal. Remember, we said gradient of a tangent times gradient of a normal is equal to -1. Right? We know the gradient of a normal. What is it? It is 13. Right? It is 13. So we're saying 13 times gradient of a normal, right? Because we know gradient of a tangent. So gradient of a normal, we don't know what it is. Gradient of a tangent is 13, right? So it is 13 times gradient of a normal is equal to -1. This therefore tells us that gradient of a normal is equal to -1 over 13. So if the question wants you to find gradient of a equation of a normal, you will do the very same thing that you did here too, because the normal is also passing through this point. Let me remind you. As you can see, the normal is also passing through this point. Okay? The normal is also passing through this point. So this is how you will be finding the equation of a normal if they ask you to look for it. Okay? So now you have seen how to find equation of a tangent to a curve, and in the same way you can also find equation of normal to the curve. Okay? At that point. Right. So now let's try a second example. I'm going to try a second example. Example number 2 will be find equation of the tangent. Find equation of the tangent. Find equation of the tangent to the curve. Let's call it f of x equals 3x squared at the point 1 and 3. At the point 1 and 3. Okay, so here, as you can see, we are given a point 1 and 3, x value and its corresponding y value. First thing first, what do? We say, okay, we know f of x equals 3x squared. What is f prime x? F prime x would be, by now you know I'm using differentiation rules, this would be 6x. Okay, this would be 6x. I didn't want to say 3 times 2 and then x to the 2 minus 1. By now you know this. If you don't know it, in the playlist of differential calculus, you can watch the second video. Okay, so this is 6x. That's the first derivative. Now what is the value of the gradient at a point x equals 1? So at a point x equals 1, x equals 1, meaning where there's x I put 1. What do we have? 6 into 1. What is that? It is 6. That's your gradient of your tangent. By the way, here you can confirm that indeed when x is 1, f of 1 is 3. Let's confirm it for you. Let me use a different color. F of 1 would be 3 into 1 squared. This is 3. Can you see that? Indeed, you have 1 and 3. Can you see that? You have 1 and 3. All right. So I showed you this method in the previous example. So cool. Now, we said this one here is your gradient, the value of your gradient, right? So what you do now is you're going to say for the tangent or equation of the tangent, you're going to say y minus y sub 1 is equal to m into x minus x sub 1. I like using this formula because it doesn't make me go back and forth. Okay, so the point given is 1 and 3. Y, where there's y1 I put 3. We said the gradient is 6. X sub 1 is 1. So this is y equals 3. Oh man, y minus 3. Y minus 3 equals 6x minus 6. So basically, we say our tangent is y equals 6x minus 3. Okay? Our tangent is y equals 6x minus 3. That's the equation of the tangent. Okay? So this is it, guys. When they ask you to sketch the graph, remember, you can use your knowledge of functions. You know how to sketch a parabola. You also know how to sketch a linear graph. Okay, so this is it, guys. And we are done. So see you next time. Bye-bye.